Well, hello guys. Let's look at Chapter 2, Section 1, Day 3. And on this video, I'm going to explain how to write the equation of a tangent line. And also let's look at how to use our graphing calculator and the derived function on that. Finally, we're going to look at what makes functions differentiable and versus continuity. So things like that. Here we go. To write the equation of a tangent line, you need really two essential pieces. One is a point, like an xy point, and the second thing you need is a slope. And that slope I'm going to capture by looking at the first derivative, okay? When I have those two things, it allows me to put it together into the format y minus y1 is equal to the slope times x minus x sub 1. We call this the point slope form of a linear function, point slope form. When we're moving into calculus, we'll still use this point slope form. This m slope I can get by looking at the first derivative evaluated at this point x sub 1, and then I'll multiply by x times x sub 1. And this would be at the point x sub 1, y sub 1. So I know my line is passing through x sub 1, y sub 1. There are really two different definitions of derivative that we can access, and we have made use of each of these. The second one here is if I had a number, let's say I wanted to evaluate the derivative at 7, well then I could use this function and it would give me f prime of 7 right away. I'd know my slope when I'm at the point x equals 7 and some y value. Otherwise, this top equation is more of a general derivative. It'll give me the derivative in terms of x's. So I think I'll probably go with this top form, the x plus h, because in class students felt very comfortable doing that. So write the equation of the tangent line. What we first want to do is find the derivative function and evaluate it at the point. The point that this one's indicating is at x equals 2, and my function I can see is a quadratic equation that is opening downward. So I'm going to go ahead. This is a g function. They had f prime there. I'm going to call this g prime of x. G prime of x will equal the limit as h goes to 0, and that captures this portion, of the function evaluated at x plus h. So everywhere I see x plus h, I am going to, or everywhere I see x, I'm going to replace it with x plus h. So this is going to look like 5 minus, I encountered the x, so it'll be x plus h. Remember, I'm substituting, and then that quantity gets squared, minus, now I'm on to the second branch. I just did this, evaluated the function at x plus h. Now I need to just evaluate the function at x, which is what I'm looking at there, 5 minus x squared. Gets divided by h. Our setup is complete, and now let's expand the algebra part of it. So I'm going to expand the terms in the numerator. That'll look like the limit as h goes to 0 of 5 minus, need a parenthesis because there's going to be a few terms here to capture, and it'll be x plus h squared. Okay, off to the side. X plus h squared. If you don't know how to square it, we can use the principle of something squared is it's multiplying by itself. Foiling this, I get x squared plus outers is an xh, inners is an xh. Last times last is an h squared. Pick up 2 in the middle. So this goes to an x squared plus 2xh plus h squared. And that is the very first stuff. Finally, let's distribute that negative, and we'll have negative 5 plus x squared divided by h. My next step is going to be simplifying. I want to simplify my numerator. So the limit, notice how I can continue to write limit over and over because the process that we're interested in is letting h go to 0, not just the algebra work here that we're running through. So I'm going to distribute my negative 3 places. I get negative x squared, a minus 2xh, a minus h squared, and then I have a minus 5 plus x squared divided by h. Still in the simplifying mode, I have an x squared and a negative x squared. That adds to 0. And a positive 5 with a negative 5, that makes 0. Notice how I have 2 functions left. I have this function and this function. They both contain an h. So let's factor out that h, the limit, as h goes to 0. Factoring out the common h on top will leave me a negative 2x minus an h to the first power. So I took an h, I took an h. Over h. Hopefully you see the beauty in this. We get an h canceling an h. Now I can substitute, maybe I'll even write that. Substitute, let's write substitute. Substitute h equals 0, and we will get negative 2x minus 0, which is negative 2x. Following my line of logic here, I have g prime of x equals. This is our derivative. We found the first derivative. It is negative 2x. In order to write the equation of the tangent line, these do get kind of long, I want to calculate the derivative at x equals 2. So now we're into writing the equation of the tangent line. Let's switch colors here. Tangent line. So I'm going to take g prime of x was equal to 2x, negative 2x. I want to evaluate at the point x equals 2, and that gives me g prime of 2 equals negative 2 times 2. G prime of 2 is equal to negative 4. That is our slope when x is equal to 2. That tangent line of striking our original curve. Okay, when we talked about writing the equation of the tangent, I needed 2 things, a point and the slope. Well, the point started off as 2 comma something, right? But they didn't give us the y value. How do I find the y value? I go back to my original function. So find y. Go to the original function. And the original function is 5 minus x squared. So g of x was equal to 5 minus x squared. If I plug in 2, when x is 2, I get 5 minus 4. I pick up 1. I have this ordered pair of 2 comma 1. Now let's write the equation and finish this problem up. Y minus y sub 1, which is a 1, equals 2 from the, negative 4 slope, x minus 2. This is the point slope form, isn't it, we're using. A long problem. You may want to replay it and listen to it again. Next problem, I have the square root of 1. I think the first thing I'm going to do here is find the original y. So the original point, if I plug in 5, I'd have f of 5 equals the square root of 5 minus 1 gives me square root of 4. Square root of 4 turns out to be 2. So I have this ordered pair 5 comma 2. When I go find the derivative, I'm going to use that general form again. So I'm going to go ahead and erase this. and that. So we have our ordered pair of 5, 2. F prime of x is equal to the limit as h goes to 0. I need to evaluate f of x plus h. So wherever I see an x, I'm replacing it with x plus h. Then I subtract 1 minus the original f of x. The original f of x is x minus 1 divided by h. If I tried to substitute 0, I would end up with 0 over 0. That doesn't help me. So what we need to do is work with the limit. And in chapter 1, we learned some techniques, especially working with these radicals. We learned how to multiply by the conjugate. So instead of a minus sign now, I'm flipping this to a positive. It really creates a difference of squares factoring. And I want to do the top and the bottom identical, so that it is like I'm multiplying by a big fat 1 here on this second grouping. Okay, the math behind this, we need to FOIL the top, and then I'm just going to write down the bottom as is, not distributing the h through. So once again, go back to your idea of distributing. I would have the square root of x plus h minus 1 times the square root. That makes this a perfect square. The square root will be deleting. The inners and the outers add up to the same quantity. They're just opposites. I'd have one positive, one negative. That will add up to 0. And I'm left with my last term. And the last times the last will give me a negative times a positive. So that'll be a negative. And square root times square root will be a perfect squaring. So I get x minus 1. Be sure to enclose that in parentheses because we have in front of it a negative sign that must be distributed. On the bottom, I get x or h times the square root of x plus h plus minus 1 plus the square root of x minus 1. Back to writing the word limit. Let's simplify on this next step. Sending the negative through on the top, through that parenthesis. And the bottom can just be rewritten. Look for the numerator to get more simplified because I see a positive and a negative in a couple places. And a positive x with a negative x makes 0. A negative 1 with a positive 1 makes 0, leaving me simply an h over an h times square root x plus h minus 1 plus square root x minus 1. H over h divides out to give me 1. And now that I no longer have an h in my denominator, I can substitute a 0 in, right? I'm left with this. Wouldn't necessarily have to write this step again. But I'm going to substitute in 0. I'm going to get 1 over square root of x plus 0 minus 1 plus square root of x minus 1. Well, that makes those two terms identical, and I have two identical terms. So here is my answer. I get f prime of x equals the general form of the derivative. Any x I want to put into this, I can come up with the slope at that point. So tracing back to the beginning of the problem, what was our point? Our point was 5, 2, the ordered pair 5, 2. So let's write the equation of the tangent line. I need to know a point, which I had. It was 5, 2, right? And I need to know the slope when x is 5. That slope will come from my general derivative. F prime evaluating at 5 gives me 1 over 2 square root 5 minus 1 gives me 1 over square root of 4 is 2, so I'd have 2 times 2 gives me 1/4. My slope is 1/4 f prime of 5. And now pieces are in place. We can write y minus the y value of 2 equals the slope of 1/4 x minus the x value of 5. And you're done. The last thing I want to do is show you how to do it with your calculator. So go ahead and bring up your calculator and give me a moment. Okay, I paused for a second just so I could get my calculator onto the screen and so it'll stay up front. We're going to find the equation of the tangent line to the graph. We're going to use the graphing calculator to do it. And there's a few ways we can do this, so I'll go through one and we'll keep going through other methods in class. The first thing I would like you to do is let's just go ahead and key this in. Go to your y equals screen and key it in. I've done so. Mine is sitting with x cubed minus x squared plus 1. Hit pause if you need to. Next thing I'm going to do, I'm just going to graph this and see what this looks like. Should be a cubic function. Definitely looks cubic, right? And when x is negative 1/2, I pick up, I'm going to bring this over. Imagine here x equals negative 1/2, so we're like right in here. The equation or the tangent line would slice through like that, wouldn't it? So this calculator can actually draw that in for us, and I'll show you how to do that just in a moment. But it also can calculate the derivative for us. So on your graph screen, so from the graph screen, we can hit that calculate button, which is sitting up above the trace key. So you need to do a second and trace. That'll take us to the calculate. So I'm going to go second, trace, and then select option 6, which is dy dx, standing for a derivative. So I'm going to take and do option 6. And then I'm going to just key in, what are we trying to do it at? At negative 1/2. So I'm just going to go negative 0.5. And you saw, as I did that, the bottom line changed. And then I need to hit enter. On the bottom of my screen, it now tells me what the slope is. Let's see, let's pull this over. So here's my slope. When I went into second calculate, I got dy dx equals 1.750. That's like 1 3/4, isn't it? So there's the slope that we captured at 1/2. If you want to see this thing be able to draw, we can go into second program, which will give us the draw menu, and option 5 will do a tangent line. I want to do it at negative 0.5 and hit enter, and there is that tangent line that we were looking at. So the calculator really has some nice capabilities, and we will explore more of those as we go through this year in calculus. All right. So here's what we got out of this. The derivative at x equals negative 1/2 is equal to 1.75. And the other thing I need to know is what is the function when I'm at 0.5. So you know what, I'm just going to go to my trace key, and I can tell I'm on the y1 just by looking. And so I want to key in negative 0.5, and then it should give me my y value of 0.625. So we have this ordered pair of negative 0.5, comma, 0.625 as an original ordered pair. And I know my slope at negative 1/2 is 1.75, which we got from the graphing calculator. Y minus the y value of 0.625 is equal to 1.75, my slope, x minus a negative will turn out to be plus 0.5, this x value there. And this is the equation of the tangent line. All right, that's enough for, I think, for this lesson. It's getting rather lengthy, and picking up the next stuff in day 4 in the classroom. Thank you.